This is a code walkthrough for the last part of the example file Array1DExamples.java. This is a long file, so we've broken it up into separate walkthrough videos, and this last part has to do with arrays of objects. So as always, let's start out by compiling this, and we will set a breakpoint here on the part that we're interested in, and we're going to go ahead and start executing this with a debugger, and it's going to screen through and set up all the data for all the array examples we've previously gone through, which leaves us here. Here we're setting up an array of objects. This is an array of CS12 dates called dates, and it's big enough to hold 5 CS12 date objects. So once we execute that, we've got this array of size 5. And notice that all of the values, because these are objects, these have initial default values of null. So the next thing we're going to do is traverse this loop. We're going to loop over the length of the array, as we always do, and set every element equal to this CS12 specific date. Remember that this general ith element of the array simply is one element of whatever type that array is. So because it's an array of CS12 dates, this date sub I element is one CS12 date. So we're just going to loop through this, and we're going to initialize all of these elements to the indicated date, December 25th, 2015. And we'll continue looping through this, and notice how here on the bottom left, all of these elements have now assumed non-null default values. And I'll go ahead and expand this so we can see everything. But as we can see, all of these 5 elements are just the indicated CS12 date of December 25th. Now in this next part, because all of these are individual CS12 dates for specific elements, we can do anything to these that we can do to any other CS12 date. So for example, we can set the date to a specific date. We can set the month. We can advance the date. So this is going to become December 26th, like so. We can equate dates. So we're going to set the fourth element equal to the second element, which is May 25th. We can make assignments, calculations, do anything we can do to a normal CS12 date. Here we're going to set up a new CS12 date object, and we're going to set its value equal to whatever is in this element, which is July 4th, 1776. So we're just reading one element of the array and setting another CS12 date equal to it. Then to print all the elements of the array, we simply loop through the array as we always do. And again, this represents one CS12 date object, so we're just going to implicitly print it using its toString method. So as we loop through this, we'll see we have the array index and the date that's found at that element. No problem. So another type of object array would be a string array. String is a class in Java, so we can set up an array of strings like so, and we'll set this one to size 50. Now we're not going to be able to see all of these elements. I think JGrasp only shows us the first 10 elements, but notice how these also have initial default null values. And what we're going to do here is we're going to set up a count of how many string objects we're actually making use of. So in this next part, we're going to initialize the first couple of strings to these specific values. Marley was dead. This is not Bob Marley that we're talking about. This is the opening line of Charles Dickens' A Christmas Carol. But what we're doing here, this 0 tells us that we're using 0 elements of this string array. This also doubles as the index of the next available slot in the array. So we're going to initialize the 0 element with Marley, like so, and update the count. So the count is now 1. And so for this next element, we'll place it at the index of 1, and we'll set it equal to the string was, and we'll update the count again, and then we'll use this count of 2 as the index of the next element that's going to receive a string, like we see here, and we'll update that, and we see that we're using the first 3 elements of the string array. Now if we wanted to print out all of the legitimate strings in this string array, this example here is how not to do it. We don't want to loop over the entire length of the array. We instead want to loop over just the utilized portion of this string array. And when we do that, we're simply going to loop over these first 3 elements and print out each string like so. And then we'll print out this message showing the difference between the actual utilized part and the full length of the array. This is kind of clumsy here, I'll have to admit. We're actually applying the toString method to a string itself to print something out. Technically speaking, this string sub I is already a string, so this toString is a little superfluous. But this is going to come into play in a moment when we show what happens when we try to do things the wrong way. If we were to try to loop over the entire length of this array, we can't apply a method of a class to a null value. It's called dereferencing, and this would cause us to generate an exception error, as we'll show here in a minute. Let's do this as a final experiment. Let's enable this bad line, let's comment out this good line, and let's take away that breakpoint up here, and let's rerun this, but let's put our breakpoint right here. Let's save it, recompile it, and let's run through it with a debugger again, and we will expand this array of strings, which are 50 nulls at this point, and we'll go through the mechanics of initializing those first 3 elements. And now we're going to try to loop through the string array incorrectly. So we're going to try to loop over the entire length of 50 of this array of strings. And watch what happens now. The first 3 elements are going to print out just fine. But now our loop index is 2. It's going to be 3 here, and we're going to try to apply the method of a class to the 3rd element, which is a null. So we're trying to do toString applied to a null, a non-existent string in this array. Look what happens now. Exception error. So when we're working with arrays of objects, we just need to make sure that we keep track of the utilized part of the array ourselves and loop only over the utilized part of our array, not the entire array. And that's really the big gotcha with arrays of objects. Okay, that's it for this example.